In the second part of the module, we will look at creating plots with Excel. The plots are great because sometimes picture is worth 1,000 words. If you have a long table with lot of entries, it's hard to understand what is in there. But if you have a nice picture diagram, it works great. In this presentation we will be working with the Pokemon Go dataset. I don't know if you heard about it. It was a game people played a while back, and I guess they are still playing it. So if you are fans of Pokemon Go, then maybe you will like it. First we will start by trying to visualize how many types of each Pokemon are there. And we'll do a pivot table, and then we will do a chart. The Pokemon Go data for every Pokemon there is name, index in Pokédex, stamina, attack, defense, the legendary Maxi P, and what generation are they from. Alright, first thing we do is do a pivot table. Is all of it, new worksheet. And what do we need? We want to have how many Pokemons of each type are there. What was the type? We will go by the primary, so I'll do primary up, and let's do index in Pokédex, and maybe some is not the right thing. I do field setting and count. Okay, up. Now for each type, I know how many of them are there. I'll sort it up. So now primary types water, most of them. Primary types flying, just one. Right, and I here pivot chart up, and pivot chart is inserted. Here you can see a little better what's the what are the numbers, how they compare to each other. If you look at the slides have the chart the other way. If you change the ordering in the pivot table, the chart updates automatically with it. Using the pivot tables, we will try to make a chart where we will try to display what is the attack distribution over generations. Right? Attack is kind of important thing, maybe more than the defense. So what I would like here has a line chart that each line corresponds to a generation, how the Pokemons are introduced, 1, 2, 3, 4, 5, and then the attack is always grouped into ranges. So the number of Pokemon is attack between 120 and 149 for each generation. You can see, right? You have these bins where you throw in all those that the attack falls into the particular bin size. Based on the bin size, this graph can look differently. Distribution of attacks over generation. You can continue from the table you had from the previous example, but my Excel managed to crash in the meantime, so I had to do it from scratch. So I'll start making a pivot table. There is a pivot table, and what do we need in the pivot table? We need I think attack. Attack. We need generation. Somewhere I'll put columns generation. We need to count how many of them. Whatever, I can put the name there. just do the count of names. Right. And now here we have for each attack number and each generation how many of them are there. This is not the most useful because the attacks are a little bit sparse, so we do this group by group selection. So we would like to have the rows, let's say start at 17, maximum 345, and you can pick how big should be the bins that you group things together by. So 17 to 46, okay. And now it looks like the data are better. And I will throw in a pivot chart. Hop. And we have a pivot chart. Oops. That. And you can change it a little bit. Design. I will make it a line chart that you don't see. Hop. Line chart like this. Okay. And you can, if you don't like how it looks, you can change the group selection. You can say you want to start at 0, start at 0 and go by 40. Okay. And now it changes. So you can change the bins, and as you change the bins, the graph changes life at the same time. The next thing we'll try to visualize is to use pie chart to see which generation has the largest number of poisonous Pokemons. So you can continue with the pivot table you already have on the previous exercise and just modify it around and create a pie chart. Pie chart is nice if you want to show proportions, how many of each things are if you have several types. This pivot table to show which generation has the most number of poisonous Pokemons. Right. So I will move this generations over here, attack, poof, and now I need the type of the Pokemon, and I will put it in a filter, and in the filter I will pick only poisonous. So now for each generation it tells me how many poisonous Pokemons are there. This is maybe not the best chart for it. Can do change chart by chart. Unfortunately, don't see how for it. Oh, and here is a pie chart that for each generation is showing how many poisonous Pokemons are there. So clearly the first generation was the most poisonous one. You may have noticed that on the previous slides there was the generation 1, 2, 3, 4, 5, but sometimes it may be nice if one instead writes the name of the region, right? So the generation 1, 2, 3, 4, 5 correspond to different regions, and what you can do to make nicer visualization is instead of the number, write the name of the region. And what you can do is use our favorite XLOOKUP to translate the number into a string. So try to do it, and when you have it, you can try to display which region has most legendary Pokemons. Legendary ones are the ones that people care about, right? Pokemon data, and we will try to do a pie chart that will show for each region the number of legendary Pokemon. So I have to figure out what the region is. For the region, I will create this lookup table. I copy pasted it here. So lookup, and I want to look at the generation, and then if I have the generation, then column S, and from column S I am translating to column T. Right. And if I double click this button, it will fill the whole thing. Right. All is in. Good. So now I will try to create a pivot table. Insert pivot table. Arrange. Okay. New worksheet. Okay. Here we have a pivot table. What are the things that we are interested in? We are interested in region, and we want to know if Pokemon is legendary, and we need to, you can use name for count, right? Through the name values that we are going to count, and legendary to filters, and I want legendary, yes, only legendary ones, and now we see which is the most legendary region, and we insert the pivot chart. We can change the design, chart type, can use pie chart, and here are some entertaining ones that you can number legendary Pokemon by it. Yeah, it's too long. And here is the chart. Important stats of the Pokemons are stamina, attack, and defense. This is trying to describe what's the distribution of stamina, attack, and defense among the Pokemons. For that, a nice type of chart is box and whiskers. So you can create it by selecting the 3 columns, and then in the menu you have to click insert chart, box, and whiskers, and we'll describe the chart in a little bit. Create box and whiskers chart for stamina, attack, and defense. What you can do is select, holding command, the 3 columns, and then here one would hope that there is box and whiskers, but you will have hard time finding it. So here, insert charts, box and whiskers. There it is. And now it shows box and whiskers chart. I will try to say quickly what the chart says. So this line, the bottom, that's the minimum, typical. The one on the top is the somewhat of a maximum, typical entries. Then this middle line is the median, the middle box is the middle 50%, and the dots that are out here, they are called outliers. So again, the dots are outliers, so this would be the actual minimum, maximum, maximums are outliers. Here minimum is not outlier. This is the bottom 0%, 25%, 50 percentile, 75 percentile, and this would be the maximum. This was the top 25%. Here is an example of a box plot or box and whiskers. You have a bunch of data starting from 57 and going to 81. And this plot in one picture shows several things. It shows you what is the minimum, which is 57. It shows you the first quartile, which is 66. Then it shows you the median, which is 70. And the third quartile, it's from 75 to 81. So it also shows the maximum. The thing in the big box, that's the middle 50% of your data. It kind of shows you the minimum, maximum, and where most of your data are. So in one picture you manage to communicate many things at once. And the nice thing is that if you have different columns, then you can have many of these box and whiskers next to each other, like we had in the previous example. Here is a little slide about explanation of outliers. You can see in the box plots that we did with the Pokemon that there were some dots that were extra. These dots were outliers. And how do you decide when a thing is an outlier? So first one looks at the middle 50%. So if I have a data, and middle 50% would be these are the big boxes, right? And if you have a normal distribution of data, whatever that means, then most things, half of them are here in the middle. And then if you take 1.5 times the width of the middle, you get almost everyone that is smaller than the middle 50%. And if you add 1.5 times the width of the 50 percentile, you get almost everyone that is bigger than the 50%. And this covers almost 100% of all the samples. But not quite, but this is how the box and whiskers diagram is. So if somebody is so far out that if I take the 50%, how much is spent by the 50%, and then do it 1.5 times more, and they are still out, then they are classified as outliers. And you should be careful that the maximum and minimum can be outliers, and they are still there. But these things should be unlikely, and not all providers of box plots will draw it with outliers. Excel provides many other types of charts that it lets you draw quite easily. So it's up to you to try to explore a little bit. Always try to pick chart that nicely depicts the data that you are trying to show. Okay. Here is an example of a pie chart that is kind of useless because it's a little bit overwhelming. It has too many slices of the pie, so pick wisely. The software lets you do charts that are not great for human eye if you let it. Yeah? And if you work hard, you may get charts that are very nice. One of the things that you can do with charts is make them misleading. One of the things is, for example, 3D charts. There was a time when 3D charts were very popular, and Excel lets you create 3D charts, but my suggestion is don't use them. They misrepresent the data a little bit. Right? If you look at the examples with the red and blue pie chart, it represents the same size in both pictures, but on the right one the red looks much bigger than on the left, just by rotation and the perspective, right? And same on the chart below. When you have the 3D bar chart, then the green on the left looks much smaller compared to the yellow than it is when you look at the chart 2 dimensions. There'll be a special presentation later about how not to, or how to misrepresent data by drawing charts. So choose your charts wisely.